All right, hopefully you guys are seeing me. Again, once you do, just type a message in the chat so I know I've got a viewer or two, and we'll get started in just a minute. We are talking exponents tonight. Okay? So there's a lot of different things in this unit, so I want to make sure that we are fully prepared, but we will actually go over the rules here first. There's actually a significant amount of rules in this unit, and they all, to me, make intuitive sense. But, I think we'll want to go over those rules first. Okay. I see that we have at least one viewer, so that means we are for sure getting started, okay? Exponent rules. Let's kind of take a look at what they are. So our different exponent rules, let's do the kind of multiplication based ones first. So first it'd be x to the a times x to the b equals x to the a plus b. Okay, so this is the rule that when you multiply two things with the same base, you add the exponents. So an example of that rule, which I'll put in red, would be x to the third times x to the second equals x to the fifth. Okay, then we'll go power of a power rule. That'd be pretty cool. Do that. All right, x to the a to the b power equals x to the ab. So this is the one that says when you have an exponent raised to another exponent, you multiply them. So example, there would be x to the third to the second equals x to the sixth. Okay, terrible six. Next is basically distributive property with exponents. Remember, you are not allowed to distribute exponents over addition and subtraction. But multiplication and division are totally okay. So this says that I can distribute an exponent when I've got multiplication. Okay, so that'd be x to the a, y to the a. Example of that would be, making at least a little more of an interesting example, something like 2x to the third would be 8x to the third, because the exponent can go to the 2 and the exponent can go to the x as well. Okay, last two rules are both division based. There's the division rule, quotient rule actually I think is what we call that. X to the a minus b is what you get when you divide two exponents, and the rule says that we subtract our exponents. So if we have x to the seventh over x to the second, we would get x to the fifth. And finally, there's this idea that you can distribute exponents over division as well. So multiplication and division are totally safe for distributing your exponents. I guess an example of that would be x, oops, I was doing my examples in red. Example of that would be x over y to the third would get you x to the third over y to the third. Those are kind of our basic rules that we use for everything, and I think the challenging part about the exponents unit is really that it's a combination of all those rules. And so we end up combining rules pretty frequently, and that's, I think, where things potentially get a little complicated. Okay, so let's go back to the beginning and take a look at some specific problems. First one, actually, all you're supposed to be doing is making a factor tree, which we all should know how to do. You can break it, remember, you're just breaking it up into multiplication, so like 40 times 10 is 400. If the number's prime, you leave it alone. If it's not prime, you continue breaking it down. So that breaks down to 4 and 10, 2, 2, 2, 5, and that 10 up there is also a 2 and a 5. I like to circle my prime numbers at the end. Maybe that's just me, but I like to. Then you will typically write it with exponents. So I have 4 2's in there, so 2 to the fourth, and 2 5's, so 5 to the second. We just did this recently with square roots in the latter half of the year, but remember we were writing it in a very particular way. Here you're just grouping all of your like numbers together. Okay, so that's making factor trees. You will have a factor tree on your exam, so yeah, get excited about that. All right, next couple are just some applications of exponent rules. So that's kind of 2 and 3 are some basic applications there. And most of the rest are just, actually most of the rest are applications of exponents rules until we get scientific notation. Okay, so here, if you look at this one, we have 2 different rules that are going to come into play. But basically the idea is first we're going to distribute that exponent. Okay, the hardest part about this is that when you distribute exponents, we know we multiply them. Okay, but we don't have an exponent on our m in the first one or our n in the second one. Okay, so what we should do there is assume that those exponents are ones, m to the first and n to the first. That'll make a little more sense now. So when we distribute in the first one, we get m to the second, n to the eighth, okay, and then n to the fourth times m to the 16th, okay? And so then the second rule that comes into play is not that we multiply exponents when we distribute them, but that now we've got a big chain of multiplication, so we're going to add exponents, but we're only going to add them on our like ones. So we'll add the exponents on the n's, and we'll add the exponents on the m's. Okay, and when we do that, it's m to the 18th, and it is n to the 12th. Okay? All right. Guys, my kid is getting a little upset, so I gotta go check in on him real quick. I'll be right back. Mic back up. There we go. All right. Let me know if anything on the mic is too loud. Sorry about that. My kid was freaking out. Joys of having a 3-year-old. Okay. That's it for that one. Moving right along. Okay. For 3 and 4, I believe what I put in the directions, yes. Okay. For 3 and 4, what I put in the directions is you should only use positive exponents. Okay, so part of this is practice in making sure you kind of use the right format. Okay, there are a couple different formats that work and are acceptable, but in this particular one, I'm telling you, make sure you only use positive exponents. There's actually a couple different ways that you can handle this. I think, though, that the easiest way is to kind of think of this, and whether you, I wouldn't assume you would write this, but like basically you're thinking of this as 3 different fractions. Okay, that's kind of what you're doing. All right, and you're just simplifying each of those. Now, I'm not expecting you to actually write that. Okay, but it's helpful to think of it in that way, I think, because now you just kind of break it down. 4 over 8 is 1/2. Okay, over here, 3 of these cancel with 3 of these, and there are 3 left. Here, in the last one, 4 of these cancel with 4 of these, and there's 1 left. Okay, biggest thing though is in all of those numerators, there's ones left. Okay, so if we actually were kind of doing this within the context of that original fraction, it ends up just being 1 over 2u to the third v. Okay, again, you don't have to write it this way. Okay, you don't have to do that. That's not necessary. You can just within that same fraction say 4 over 8 is 1 over 2. 3 and 3 cancel, and I get u to the third. 4 and 4 cancel, and I get v to the first, or just v. But the big thing is, you have to put that 1 in your numerator, so no matter how you break it down, no matter how you look at it, that should be your answer. There's a way to do it with exponents as well. Okay, or there's a way to do it with negative exponents as well, I should say, but we'll save that for a later one. Okay, this one we're going to do with positive exponents as well. All right, distribute your exponents. Okay, when you do that, you multiply m to the 56, p to the 49 over, okay, and I'm going to actually show this. It's 2 to the 6th, m to the, m to the 24th. Not turning out well. Silly iPad. M to the 24th, n to the 24th. Okay, so now you when you do it, if you want to just do 2 to the 6th, go right ahead. Okay, but I wanted to make sure that I kind of did that one right. Okay, and showed you exactly why that number was there. Otherwise, I was afraid I was going to get questions about where did this next thing come from. Okay, so now 2 to the 6th is all that's going to be left on the bottom. 2 to the 6th is 64. Okay, and then on top, 24 and 24 are going to cancel out. So that is 32 left. And 24 and 24 cancel. Oh, wait. Almost made a mistake. Almost went on autopilot. Sorry. Different variables. Those do not cancel. Those will actually both stay there. So it's still p to the 49 and n to the 24 we will leave on the bottom. Almost made a mistake. Saved myself. Got a little lucky. Okay. Now, on 5 is basically where I want you to start practicing working in 2 different formats. So I'll show you the 2 different formats that you can give as an answer here. Before we can even worry about any of that, we want to distribute our exponent. Okay. Okay, so that's what we get when we distribute. How you deal with it from here is really entirely up to you. There are just so many ways to deal with it, okay? We've got some negative exponents. We could do some exponent subtraction. We've got this lonely v to the negative 12th on the bottom here. Ugh, not a lot of great ways to deal with it, okay? What I might suggest is on this one, and this is kind of a special trick that you can do, if you move negative exponents from denominator to numerator, or the other way around, you can turn them positive. So what I'm basically going to do is I'm going to take these 2 terms right here and I'm going to switch them. Okay, and then rewrite the problem using only positive exponents. This is something you can always do because of the fact that those exponents are related by a reciprocal. Okay, so I'm going to box that in, especially if you're watching that later, it might make more sense. So those are the 2 terms that I moved, okay, and it's where they are now. So I moved that u to the negative 4th down to my denominator and made it positive, v to the 12th to my numerator and made it positive. I just feel like it's easier to work with positive exponents because now we can just kind of cancel things out, right? We've actually got 2 different situations here, 3 different situations. We've got our 2's, which we can now just cancel out and say there's a 2 squared left down here. Our v to the 12th will cancel with absolutely nothing because there's no other v's, and these 2 will get multiplied together because they're both in the denominator and they'll turn into u to the 8th. So we get v to the 12th, u to the 8th in the denominator, and 4, just a regular 4 down to my denominator because that's what 2 to the 2nd is. Okay. Another way though that you could write it, which would probably be what you'd get if you did just exponent subtraction. Okay, so let's kind of mentally go back over here and just literally do this with exponent subtraction instead. Okay, so on my 2's, I can subtract those exponents. I get 2 to the negative 2. My u's, I can subtract those exponents. I get u to the negative 8. And the challenging question is, what do I do with the v's if there's no exponents for me to subtract? Well, guys, here's a trick. Don't have to do it exactly this way, but basically you can assume there's a v to the 0 up there. And the reason you can assume that is because anything to the 0 power is 1. So we can subtract those exponents and get v to the positive 12. Okay, if we simplify from there, 2 to the negative 2 is 1/4, u to the negative 8th, v to the 12th. And these are kind of the two different ways that you can write your answer. Okay, the one in blue is with all positive exponents. Okay, and the one in gray says negative exponents are okay, but notice how I haven't used any fractions, and I tried to make it pretty clear that I was putting my 1/4 fraction next to there. Okay, Dara just asked a really good question for these especially. Is there a way to check your answers without going back and doing the problem again? In a lot of situations, the answer is yes. In this situation, it's not no, but I feel like those ways are about as difficult. One of the things you could potentially do is basically use a calculator and plug in numbers. So like you could basically pretend u was a specific number, maybe like u equals 2 and v equals 3. And you could plug the original problem into a calculator and your answer into a calculator and see if they match up. Honestly, guys, there's a whole lot of places where you could then just go wrong. Okay, especially on the calculators you guys use. Okay, so I wouldn't necessarily recommend it. So I feel like that's a judgment call to make. Let me think on that a little bit too. I'm not really sure. There might be a better way that you could potentially check. Ali asked a good question too. Do we have to show both ways on the test? So there will be at least one place, at least one problem, and maybe just one problem, just kind of like on this review here, where I make you show both ways. So yes, you do need to be able to put it in either format. Now that doesn't mean that you have to actually do it both ways though. Okay, so like you could just go from this one that I just am circling in yellow right now, and then just say, oh, I'm going to turn that u to the 8th into u to the negative 8th and just rewrite it. You don't have to do it both ways. Okay, like you don't have to show two different methods of doing it to get to two different answers. You just have to get to an answer and then be able to write it in two different formats. Okay? Guys, the rest of the unit was all scientific notation, okay? And it's the one thing that I really didn't talk about a lot in terms of exponent rules. But the rules are really pretty simple. Everything will look like this. A times 10 to the n, okay? And we have some specific restrictions on A, which now that we've done inequalities, I can just write like this. A needs to be greater than or equal to 1, and A needs to be less than 10. Okay, so again, can't be 10, but it can be anything smaller than 10. It could be 1 or anything bigger than 1. Okay, so we're looking basically for a single digit number with a decimal. Okay, and I'm just going to show you how to convert back and forth. Okay, so for this first one, I've given you a number in scientific notation, and we want to try to write it in standard form. Okay, so writing this one in standard form, basically this is saying multiply by 10, because it's a positive exponent, multiply by 10 3 times. Anytime you multiply by 10, you just change the place value by one place value. Okay, so you're changing the place value, you're changing the place value, you're changing the place value. We get 1, 1, 2. Now, technically our decimal place is out here, and we kind of hopped one place value there. Okay, so what we do is we stick a 0 in there. So this should be 1,120. This would show us how to go the other way. So this one, because it's a negative exponent, says divide by 10 2 times. So we divide by 10 twice, and again, stick in a 0 where needed. okay? Where sometimes there are trouble are on the next two where you're converting into scientific notation, okay? Basically, what you want to do is this. You want to look at the number that's given to you and figure out where would I put a decimal place to turn it into a number between 1 and 10? Well, in this one, I'd put it between the 4 and the 8. Okay? That's now a number between 1 and 10. I'm going to erase my 2 zeros because now that it's a decimal, I no longer need it. Okay? Then I want to write my times 10 part, and then for the exponent, I'm figuring out what would I have to do to 4.8 to get it to be the original number. Okay, well, I'd have to multiply it by 10 3 times. So that's a positive 3. I get a lot of a negative 3 exponent on that one. But again, it's this number should match this number. So if I go back that direction, I should get my original number. That's why I need a positive exponent, because it's bigger. Okay, and I'm multiplying by 10 3 times. I'm not dividing by 10 3 times. I'm multiplying by 10 3 times. Literally exact opposite for this one. I would make this number 6.5. And I would have to divide by 10 1, 2, 3, 4 times. So it's a negative 4 because I'm dividing by 10 4 times to get back to that original number. Okay? And finally, the real power of scientific notation is multiplying and dividing, okay? Because you don't have to multiply really big or really small numbers. You can just do it using exponent rules, okay? So you're going to end up multiplying the number parts. So I get 12. And then because we're multiplying, we add exponents when our numbers have the same base. So negative 6 plus negative 1 is negative 7. So I get 12 times 10 to the negative 7. And here's the, while I'd still rather do it this way, this is the one annoying part. Now I got to write my answer in scientific notation. Okay, and unfortunately my original number is not between 1 and 10. Okay, so again, what I have to understand is I've got to change that to a 1.2. Okay, but because I did that, okay, I just dropped the place value on this part of the number. This is all one number. Okay, we got to understand that that 12 times 10 to the negative 7th, that is all one number. Okay, so if I'm changing that place value, like I'm dropping that place value, making it go down by 1, I got to make the place value, so the exponent on my 10, go up by 1 in order to get those to match. So if I go from negative 6 and I go up 1, or if I go from negative 7 and I go up 1, I get to negative 6. Okay, so you should get 1.2 times 10 to the negative 6. Okay, and our last one, we are going to do almost the opposite of what we just did. We are going to divide the numbers, so these, and we are going to subtract the exponents. Okay, 4 divided by 5, you're going to have to write that as a decimal because we can't have fractions in scientific notation. Okay, so I'm going to change that to 0.8. Oh darn. 0.8. 4 minus negative 2. This is another place where we go wrong because we remember we're subtracting, but then that negative gets in there and it's like, 4 minus negative 2 is 6. So I get 4 times 10 to the positive 6. Okay, again, I've got to change that place value. This turns into an 8, and because I increased my place value of that number, I have to decrease my exponent to balance it out. I get 8 times 10 to the 5th. Okay, guys, that's really it for the exponents unit. This was in a lot of ways a tricky unit just because there seems to be a decent amount of information. One quick thing I want to show you. I'm going to add one problem. It's a special bonus just for those of you that are watching either live or later on. Okay, so if you watch it, kudos to you. You get a bonus problem. Okay, bonus problem is this. 2x squared y to the negative 3 all to the negative 3. Okay, I'll actually give you a second if you kind of want to try that either mentally or on a piece of paper or whatever. And I'll just give you a second to do that. Dara asked a good question anyway, so I have a chance to talk about that. If there was an exponent on the brackets that contains scientific notation, would it affect the exponent like it regularly would any variable? That's a great question. Yes, it would. Okay, so let me quick write a side note over here. Okay, I'll do that in green, separate from our super bonus problem. So like an example would be like 2 times 10 to the 5th to the 2nd power. You would actually distribute this exponent very much the same way. Okay, so it would go here and it would go here. It doesn't go to the x because that's not an x, that's a multiplication symbol. Right? We got to be real careful with scientific notation. Okay, so we would get 2 to the 2nd times 10 to the 10th. I would multiply my exponents again. And then I would rewrite my 2 to the 2nd as 4. And I'd get 4 times 10 to the 10th. Okay, so yeah, it would actually work very similarly, and it would affect it just the way it would any exponent. It wouldn't affect the 10, just affect the exponent. Okay, our super bonus problem, you would distribute the exponent, and you would get 2 to the negative third. I'm putting that exponent there on purpose. I don't want to jump and just do the exponent right away because I want you to see that that's there. X to the negative 6th, y to the 9th. Okay, so I literally just multiplied exponents. Okay, and where there wasn't one, so like on the 2, I gave it the exponent of negative 3. The only thing I have to do here, and the only reason I gave you this problem, is because of that 2 to the negative third. Remember, this is one of my pet peeves. Negative exponents mean division. So instead of multiplying by 2 3 times, I'm dividing by 2 3 times. So I start at 1, I divide by 2, I get a half. I divide by 2 again a second time, I get a fourth. I divide by 2 again, I get an eighth. This is 1 over 8. X to the negative 6, y to the 9th. Okay? Big on those negative exponents, especially on numbers, guys. We got to know what they do. Okay? Hope this was helpful. If you have other questions on exponents, feel free to talk to me when you see me at school, and hopefully I will be able to help you out. Yes, Ali, thank you, as always. #math. Thanks for watching, guys.